Welcome back to equation of a straight line. Two lines, we have been given a structure equation of 10 marks. Two lines, L1, 2y minus 3x minus 6 is equal to 0. And L2, line 2, 3y plus x minus 20 is equal to 0. Intersect at point A. Find the coordinate of A. Part B, a third line L3 is perpendicular to L2 at point A. Find the equation of L3 in the form of y is equal to mx plus c, where m and c are constant. The last part of that question, another L2, L4 is parallel to L1 and passes through negative 1, 3. Find the x and the y intercept of L4. Let's look how we can work out. Starting with the first part of that one, we have been given the two equations. Therefore, rearrange them in the form y plus x is equal to c. We rearrange and they form what we call the simultaneous equation. We solve this simultaneous equation by elimination method. You can use even substitution, no problem. For in case of elimination, we need to eliminate x. So multiply the coefficient of x in equation 1 in equation 2, giving us 2y is equal to 3x is equal to 6. 9y plus 3x is equal to 60. Now subtract equation 2 from equation 1, giving us 11y is equal to 66. Y is equal to 6. But what is x? X is equal to, using equation 2, x is equal to 20 minus 3y. But our y is 6. Therefore, our x is equal to 20 minus 18, which is equivalent to 2. So the point of intersection A is 2, 6. Part B of the equation, a third line L3 is perpendicular to L2. So if it's perpendicular to L2, first of all, we must find the gradient of L2 by arranging your equation of L2 in the form y is equal to mx plus c. The coefficient of x is the same as the gradient of L2. If that is the gradient of L2, let's find the gradient of line 3 because it's perpendicular. The product of the gradient of two perpendicular lines is equal to negative 1. Therefore, the gradient of our line L3 is equivalent to 3. How do we obtain 3? Negative 1 divided by the gradient of L2, which is giving us 3. So we have been told that it passes through which point? At point A. Let's find its equation. Now, if we have the gradient and we have the point of intersection where it passes, therefore we take another arbitrary point xy. This therefore becomes y minus 6 because this is our point. All over x minus 2 is equal to 3. By crossing multiplication, y is equal to 3x minus 6 plus 6. Therefore, our equation will become y is equal to 3x. That is part B of that question. Let's see part C. Part C was saying L4 is parallel to L1 and passes through negative 1, 3. If it's parallel, they have the same gradient. How can we do about that one? So first of all, we must find the gradient. Gradient of line 4 is equal to the gradient of line 1, which is our gradient of line 1. Rearranging this one in the form of y is equal to mx plus c becomes 3 over 2. Taking arbitrary point, our arbitrary point y minus 3 all over x minus becomes 1 plus 1 is equal to this one. Substituting this one, giving us the equation 2y minus 3x is equal to 9. Remember, our point was not to find the equation, is to find x and the y intercept. when x-intercept at y-intercept x is equal to 0, therefore y is equal to 4 point, substitute in your equation 4.5. X-intercept y is equal to 0, therefore substituting 0 on your main equation where you have y, therefore x is equal to 3. And that's how we solve such questions.